Okay, so today we proceed with the next subtopic regarding the forces in equilibrium. Technically, we have learned about the Newton's law of motion regarding the Newton first law, Newton the second law, and Newton third law of motion. So in these forces of equilibrium, we are going to find out or we're going to see the forces that is not in the y component and the x component. So we have an object over here. Let's say this object is at rest, all right? When you say the word at rest, that means it is static lah. No motion, no movement, no velocity on the ground or on any surface. So when an object, of course, it has mass. On the earth, of course, it has the weight. So weight always pointed downward. Okay, and based on Newton's law of motion, when we have an action, which is the applied force or any force, we will have the reaction force or we have the opposite force. So over here, when we have the W, which is straight downward, so we have another force, which is straight upward. All right. And this force is known as the normal force, or I just label with the letter W. So this normal force always perpendicular to the surface. In this case, it is perpendicular to the ground. All right, so now let's say we have a force applied to this object. Let's say now we have the force which is F. All right, this F is the applied force. Maybe we want to pull this object towards to the right. Okay, so we have the applied force, and this force, if you notice, it is not on the y component or in the x component, which means we have to solve or resolve the forces respect to y and x component. Normally, when you are given this type of force, you will be given the angle, right? So let's say angle over here is 30 degree. So we can solve this based on the triangle, all right? So I'm just going to hold for a while this diagram, and I'm just going to copy the forces, the applied force. Okay, so we have F and we have 30 degree over here. So this F, right, is in between X and Y component. So we can solve for the Fx and also for the Fy. So we can make this becomes the triangle by transferring or removing the Fy to the right. So we can have the diagram more like this. So this one is our Fy, this one is our Fx, and this is our F. So we have the triangle already. So technically I'm just removing this into this. So, but the 30-degree angle still unchanged, which means around here it is 30 degree. So we have 30-degree angle over here. You are given the F over here. You have the value of the F. You have the angle. So literally, we can find the Fy and Fx based on the triangle that we have learned in mathematics for the right angle triangle. For the right angle triangle, this is 90 degree. If this is the theta, so we know the value, this one is the opposite. I just write the OPP. And the next one, which is the adjacent, I just write ADJ. All right. And the one opposite with the 90-degree angle, we call as the hypotenuse, which is the hypo, HYP. And we have the formula, which is literally, you have memorized, is the SOH, CAH, and TOA. So we have sine theta equals to opposite over hypotenuse, cos theta equals to adjacent over hypotenuse, and the last one is tangent theta equals to opposite over adjacent. So in this case, You are given the theta is 30 degree. You have the hypotenuse. Let's say we want to find the value of Fy. So we can just key in the value, all right? We want to find the opposite. Fy is the opposite. Capital F is the hypotenuse. So we want to find the opposite. And you are given the hypotenuse. So opposite hypotenuse. So we can key in the value of sine theta. Sine theta is 30 degree equals to sine 30 degree. We have equals to opposite. Opposite is our Fy. Over with the hypotenuse is capital F. So we can find the value of Fy by transferring F times with sine 30 equals to Fy. So we can find the value of the Fy, which is equals to F sine 30. We can also find the value for the Fx. Fx over here would be the adjacent. So for the adjacent, you have the hypotenuse. Adjacent for the hypotenuse, you are given, you can key in the value of the cos theta. So I'm just going to do at the bottom here. So cos theta or cos 30 degree equals to adjacent is fx divided by hypotenuse is f. So we can find the value of fx, which is fx equals to f cos 30 degree. Okay, so this is the concept of the cos sine regarding the forces in equilibrium. Okay, so next we can proceed with the exercises. Thank you.